Hi, so apologies for the rushed video and probably very bad camera angles that you're about to witness, but I thought it was most important to get this out first. I'm going to be trying to get as many plans and details and measurements and things out in the next 24 hours, a couple of days. I thought I'd get the basic principle of what I've developed out as soon as possible so that people could start to think about it and see if they have any ideas or any feedback. So I know that this obviously won't be a safety critical piece of equipment, and I certainly know it's not very pretty, and there's nothing very high tech about it. But part of that is the point. So this is designed to be made in any shed or workshop around the world. So there's no special parts, no 3D printing, no metal work. It's just something I've put together in the basement with a few bits of wood and a windscreen wiper motor ripped out of a car. So I've spoken to a respiratory doctor who's a friend. He said the most important things to think about with ventilation was being able to control the volume that you're able to provide to someone, that there's a pressure safety system in place, a pressure release valve, and also if you could measure pressure, that would be great. You need to be able to change the cycles per minute, so the number of breaths you take a minute, and also controlling the ratio. So at the moment it's set to 1 to 2, but I'll talk about that in a minute. So to talk you through the design, this entire thing runs off either runs off a 12-volt car battery, so it could be used anywhere in the field or anywhere without mains power. But if you've got a 12-volt power supply that plugs into the mains, you could obviously use that as well. So that goes to a little motor controller. So this can be bought anywhere. This is just a really cheap one off Amazon. For the motor I'm using, about 5 amps would probably do. I think this one goes up to 15, but again, very, very cheap, really accessible. So that is connected around the back to this. So this is a windscreen wiper motor off a car, so it's fairly low speed but very high torque, which is great because it means it's got enough force to be able to squeeze the bag when it applies the pressure through the camshaft. So the cam itself, I've got an Excel sheet which has worked this out, which I'll be getting online as soon as possible. This rotates with a 2-to-1 inspiration to expiration ratio, so you spend twice as long breathing out as you do breathing in. You can change this, so if you wanted to have a 1 to 1.5 or a 1 to 3, you can just put the numbers in. I've got an Excel sheet and that'll work it out for you. But at the moment this is 1 to 2, and it's a linear input and output, so it ramps up and it ramps down in a linear way. I don't know if it's better to ramp up as you're breathing in and then ramp down as you're breathing out. If you know, let me know and I can redesign that with a slightly different profile. So back to the design. The camshaft goes down onto just a bearing, but you could use a bit of metal or a slider plate, anything to try and keep the friction low. That's kept pressed against the cam by it's just a rubber band, but a bit of elastic would do, and also there's an extra safety feature on top that will bring the arm back up in the case that the band snaps or anything. So as the cam rotates, that compresses the bag, and you can change the volume it compresses the bag by shifting it up and down this beam. So it's pivoted at this end, so if you move the bag towards this end you decrease the volume, and if you move it closer towards the camshaft you increase the volume. So just to give you a demonstration of that, if I take the speed controller, move it up, so you can control the cycles per minute by varying the speed. See there at this end you get a lot of bag compression, and again apologies for the shaky camera angle, but I will try and move this one-handed. If I now move this further back, you get less compression, so you get the same ratio, inspiration to expiration, you get you get the same rate, you just get obviously less air for So you can set this based on I think ideal body weight to give the right amount of air. The markings I've laid out are just on tests that I've done. So if you make a device for anywhere, you would have to calculate the volume of air coming out. You can do that by just filling a bag, putting it in a volume of water and seeing how much water spills out, and then make appropriate markings so that someone could just move it up and down and know, roughly, I think it's within about, I can't remember exactly, so I don't want to say, but so you could get it roughly within the right region for whoever you're trying to administer this to. Now, obviously this is quite a large bit of equipment, so I've used a bit of pipe. I think you can get proper pipes to fit these bags. I didn't get the right ones, I've just had to sort of gaffer tape it up. But that then takes it up to the mask. Now the mask has its own little pressure relief valve on the top, so that's set to 60 centimetres of water. But a very simple system for measuring the inspiration and expiration pressure that I've come up with to go alongside this is here. So this is a small bottle of water, which essentially has a plastic tube running into the bottom of it, and that level of water there is set to the 0 centimetres of water pressure, and then that tube extends all the way up to 70 centimetres. Now, as another safety feature, if you leave the top of this open, you need to anyway to make sure it equalises the pressure, if anything over pressurises, it'll just shoot out the top. And so there's a second tube here that just comes in above the water level, so that when you pressurise this area, it presses the water down and you get a clear visual output of the pressure going up and down this scale. So now I'll see if I can demonstrate that. Move this in, take a large volume, speed that up. There we go. So this little pipe would go inside underneath the mask. Alternatively, I think you could fit it at some point, but you'd need to make sure you have a really good seal so you're not losing any air. And then if I try and hold my hand down against it, you can see the pressure going up and down with the breathing rate. So that's the design. I'll try and publish as much information, measurements. I've got a set of measurements and I've done the CAD, so I'll get that up as soon as possible. But if you have any other ideas for how I could make this better, how we could make it more effective, if there's anything else that I'd need to include, then just please drop me a message. I'll try and get this on as many websites as possible, but I think this will probably first go up on Instructables. So thank you very much.